Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching PU2 Brahmastra Series, where we are trying to help you to achieve out in your PU2 final exam. And today is day 5 of this series, and I am here to discuss about the second chapter of physics, very important chapter, electrostatic potential and capacitance. First, as usual, we will look into the 3 blueprints, what are the marks distribution for this chapter, and then we will discuss how many questions we are going to solve, and then we will start with all the questions. So without any delay, I will start this series, but before starting, I request you to join our WhatsApp channel so that you get all the updates whenever we are updating a new video, new series, anything coming new, you will get the notification. And secondly, also fill the form. The form link is also given in the description. You will get the class notes directly to your email, to your WhatsApp. So what are you waiting for? Do these 2 things first, and then you can start watching this video. Now let's start with the marks distribution for this chapter. So there are 3 blueprints. In 2 blueprints you can see that they are allocated 10 marks, and in 1 blueprint they have allocated 11 marks. So this is a very important chapter. Okay, out of 70 marks, 10 marks you can answer from this chapter alone. So this is very 1/7 of your marks, right? So this is very important chapter. Let's see what are all types of questions are coming from this chapter. So in terms of MCQ, you can see that in the first blueprint they are saying 1 remembering based MCQ. In the second blueprint they are saying 1 remembering based MCQ. In the third blueprint they are saying 2 MCQs. One is remembering based, another one is HOTS question. So this is little typical, some understanding level questions, some calculation level questions. So 1 MCQ will be easy, 1 MCQ will be slightly difficult. Okay. Now in terms of fill in the blanks, only first blueprint is giving 1 fill in the blanks, rest of the blueprints are not giving any fill in the blanks question. In short answer type question, 2 marks question, that is there is no question in blueprint 1. In blueprint 2 only 1 question is coming. Again in blueprint 3 there is no question from this section. Okay, now in short answer type, 3 mark question, you can see 1 understanding based question in blueprint 1, 1 remembering based question in blueprint 2, and 1 remembering question in blueprint 3. So definitely 1 3 mark question is coming from this chapter. No matter what blueprint they are following, 1 3 mark question will definitely come from this chapter. Now in long answer type question, in blueprint 2 there is only 1 case where they are giving you 1 long answer type question, that is derivation based question, which is understanding. Also this will be a split question. What is the meaning of split question? Split question means it will not be a single direct question. They will give you they will ask you the question in parts. Okay, so state, suppose they what is the potential due to a what is defined potential, then find that potential due to a single point charge. So like that. So there will be 2 part questions. Okay, we will see that while doing these derivations. And in the long answer type questions, there will be in blueprint 1 and blueprint 3 we are seeing there is a numerical question. So there is a high chance that a numerical question comes from this chapter. Okay, there is a very high chance. Otherwise there will be a numerical long answer type 5 marks question from this chapter. Now let's start. Let's look into all the questions that we are going to do. So 15 we are doing MCQs, 5 we are doing fill in the blanks, 5 we are doing short answer type, 4 we are doing short answer type 3 marks, 3 we are doing long answer type, and 3 we are doing numerical questions. Okay, now let's start with the MCQ questions, 15 MCQs. Let's do it faster. Last time I took a lot of time, so students were saying that, sir, please do it faster, your lecture is getting longer. So I will try to keep this lecture as crisp and as short as possible, but it will be slightly more than 1 hour, so don't worry, but I will try to do my best, try my best to keep it as short as possible. Okay, so start with the first question. The angle between equipotential surface and electric field is. Now these MCQs are based on your model question papers as well as previous year question papers. Okay, so angle between equipotential surface and electric field. So equipotential surface and electric field, they are always the angle is always 90 degrees. Okay, the angle between equipotential surface and electric field, they are always perpendicular to each other, so the angle is 90 degrees. Next question, what is the total charge on the parallel plate capacitor as shown? So in the parallel plate capacitor, total charge, as you can see, this has a charge, positive plate has a charge Q and the negative plate has a charge minus Q, right? So what is the total charge? Quickly. Yes, total charge is 0. Those who are saying Q and minus Q, they are wrong. Total charge is addition of these two charges, so total charge is 0. Okay, now question number 3, the capacitance, this is from your last year question paper. Okay, this is from 2024 question, directly taken from that question paper. The capacitance of a capacitor, this is a HOTS question. Okay, the capacitance of a capacitor is 6 times 10 to the power of minus 6 farad. It is connected to a 200 volt cell. The energy released on discharging it fully. So energy released in discharging it fully means whatever energy was stored in the capacitor, that energy is getting dissipated. So that much energy is released, right? When we charge a capacitor, what is the energy stored in the capacitor? The energy stored in a capacitor, we know that is given by half CV square. So energy stored in a capacitor is given by half CV square. So from there we can write that here half C is 6 times 10 to the power of minus 6, V is 200 whole square. So it will be half 6 10 to the power of minus 6 times 4 0 1 2. So 2 square is 4, and when you are squaring the zeros, there will be 1 2. So 2 zeros was there, so you have to make it double, 1 2 3 4. Okay, if 3 zeros are there, it will be 6 zeros, right? So now 4 zeros means what? 4 zeros means 10 to the power of 4, right? 4 zeros means 10 to the power of 4. So we can write this as 10 to the power of 4. So, and this 4 is cancelled, so we got 2. So 2 6 are 12 times 10 to the power of minus 6 plus 4. So that is 12 times 10 to the power of minus 2 or 0.12 joules. Okay, so 0.12 joules is the answer. Just apply the formula and calculate it. Okay, simple, and you get enough time, so no need to worry. Take your time, solve it slowly. Okay, don't go it fast. Okay, now next question, if n identical capacitors of capacitance C is connected in series, then the equivalent capacitance is. So here n equivalent capacitors of capacitance C are connected in series. Now in case of series connection of capacitors, we know that equivalent capacitance is given by 1 by C eq equals to 1 by C plus 1 by C plus 1 by C plus dot dot dot. Right? So for series connection it is 1 by. For parallel connection just addition. Right? So in case it will be n by C, or C equivalent will be C by n. Okay, so when n equivalent capacitance, n equal capacitance are connected in series, the equivalent capacitance just becomes 1 by nth time that capacitance value. Okay, now next question, question number 5. If charge in a capacitor is doubled, then its capacitance is. So very interesting question. I am giving you 2 seconds to answer this question in the comment. Okay, if you know, then we will see. The capacitance of a capacitor is independent of the charge. Okay, it gives you the maximum amount of charge it can store based on the potential that you apply, but capacitance is independent. So capacitance will not change based on the charge is there in the capacitor. Okay, voltage potential will increase, right? Q is equal to C, even though Q is equal to CV, okay, C is constant. Okay, C is basically Q by V. So if you double the amount of charge stored, so V will adjust automatically so that C remains constant. Okay, so if you double the charge, voltage will be doubled also, but capacitance will remain same. Okay, so this is also another objective. They might ask you the same question, that if the charge is doubled, what will happen to the potential? Potential will also be doubled, but capacitance will remain same. Okay, next question. At the surface of a charged conductor, electrostatic field must be. This is some properties of electrostatic field that is given in this chapter. Okay, so you have to remember that at the surface of a charged conductor, the electrostatic field is normal to the surface at every point. Okay, so when a charged conductor is taken, electric field at any point is normal to the conductor at every point, right? Now, next question. The electric field inside the cavity of a charged conductor is 0. This is known as, this question is from 2023 final exam. Okay, the electric field inside the cavity of a charged conductor is 0. This is known as electrostatic shielding. Okay, so inside a cavity, you may remember a diagram like this. So it is like this. So if you have a charge, some electric field outside, inside the electric field is 0. So this is called electrostatic shielding. Okay, inside a charged cavity, the external electric field has no effect. Okay, it protects any instrument which is stored inside this cavity. So that is why it is called electrostatic shielding. Next, question number 8. Dash dielectric develops a net dipole moment in the presence of an external field. Okay, only polar, only non-polar, both polar and non-polar, no dielectric. Okay, so basically let's see the options. Only polar dielectrics develop, only non-polar dielectric develops, both polar and non-polar dielectric develops, no dielectric develops. Okay, so to complete this sentence, that's why there is a no here. Now, the answer to this is every dielectric, no matter it's a polar or a non-polar, both develops net dipole moment in the presence of external electric field. Okay, now in case of polar dielectric, there already exists net dipole moment, but in presence of external electric field, this becomes higher. But when you are considering a non-polar dielectric also, they also develops a net dipole moment presence of external electric field. Okay, so this is a very interesting question. From your NCERT book, directly taken from that book. Okay, so if you have read this, you could answer this question. Next question. Which of the following is discontinuous across the surface of a spherically charged conductor, spherically charged shell? Okay, which of the following quantity? Okay, so what are the options? Check the options. Only electric field, only electric potential, both electric field and potential, only gravitational field. Okay, so but obviously this question is related to electric field, so we can electric field and potential, we can simply ignore this. Okay, so only thing we need to consider is electric field and electric potential. So now we have a charged shell. Okay, charged shell. Okay, and what is discontinuous? What is the meaning of discontinuous? Discontinuous means it starts suddenly. Now if you remember the graph of electric field in case of a shell, okay, the shell graph was like this. It is flat like this, and suddenly it's starting with like this, right? Now if you remember, for the electric potential, the graph was something similar. Okay, this is for electric field. Okay, and this is the distance r. Now I will plot the graph on the same thing but with a different color. For electric potential, it is like this, and it is falling like this. Okay, similar but slower than the electric field. So you can see that at this point the function is continuous. Okay, it has a value here, the same value is here. So you have learned the continuity in your continuity and differentiability in mathematics class, right? So if a function is continuous, if you go from here, if you go plus and minus, you should get the same value. right? If you approach a point from the both side, you should get the same value, then we say this is a continuous function. Similarly here, if you see, if you go from this side for electric potential, you will get a constant value. If you approach it from this side also, you will get the same constant value. But in case of electric field, if you approach it from this side, you will get a value, but when you approach it from this side, electric field is 0 here. So electric field is not continuous. So only electric field is not continuous, whereas electric potential is continuous. So answer is only electric field. Okay, so discontinuous is only electric field. If they ask you the same question based on which is continuous, then will be electric potential. Okay, electric potential will be continuous, whereas electric field will be discontinuous. You have to remember this thing. Okay, you can remember it this by from the graph, from the definition of continuity, or by just memorizing it. Okay, now let's move on to the next question. Potential due to a charge at its own location is, so potential due to a charge at its own location, so you have a charge here, okay, and you want to find the potential exactly at this point. So this is not defined and its value is infinite. Okay, it is infinite. Potential at the location of the charge is infinite. It is not defined or infinite. Both are somewhat correct. If you put r equals to 0, then you will get potential is equals to 0. Potential, what is the potential? Potential is kq by r, right? So at its own location, r equals to 0. So r equals to 0 means potential will be infinite, right? This is the easiest explanation. So the answer is infinite. Next question, number 11. The capacitance of an air capacitor is C0. A dielectric medium of dielectric constant K is inserted between the plates. Okay, the new capacitance will be. This question either come like this or it can come on the other way also. Okay, the capacitance was K C when the dielectric medium was inside. Now dielectric medium is removed. What is the capacitance? Okay, so the answer, to answer this you have to remember the formula. Okay, epsilon naught A by D. This is the capacitance of a parallel plate capacitor, right? Now if you add a dielectric, then the capacitance will be K epsilon naught A by D, right? So this is when you add the dielectric medium, or you can say this is K C naught. So the answer is K C naught. Okay, or if you remove it, it will be divided by. Okay, when you add, it will be multiplied. If you remove, it will be divided. Next question. The electric potential due to a negative point charge at a distance r is. So the question is the electric potential due to a negative point charge at a distance r. So electric potential due to a point charge is K Q by r. Okay, so negative point charge, so charge is negative, so electric potential will be K minus Q by r. So it will be minus KQ by r. So it will be negative and varies with 1 by r. Okay, so electric potential will be negative and it will be varies as 1 by r. Clear? Now next question. The values of electric field E and electric potential V at any point on the equatorial plane of an dipole are such that, so here we have a dipole, okay, plus Q minus Q. So they have asked you on the equatorial plane what will happen to the electric field and electric potential. Now we have already calculated the electric field yesterday, not yesterday, in our previous class, okay, class number 2. So there we have discussed that electric field is not 0 and it varies with 1 by r cube, right? But electric potential, when you calculate electric potential, you will get that electric potential is 0. Okay, you can try that. Both the distances are same, so you can take this distance x, this distance x, okay, and both the distances are same, but charges are opposite in nature, so they will cancel each other. So electric field will not be 0, but electric potential will be 0. Okay, so electric field is not 0, electric potential is 0 on the equatorial plane. Okay, You have to remember this. Very interesting question might come. Next question. Which one of the following is the unit of capacitance? Easy question. Farad, Coulomb, Volt, Tesla. Only Farad is the answer. Okay, Coulomb, Volt, Tesla are not unit of capacitance. Last question. A spherical conductor of radius r is carrying a charge of plus q. The ratio of electric potentials corresponding to a point on the surface of the conductor and at a point at a distance 2r from the center of the conductor are in the ratio. So the ratio of the electric potential corresponding to the point on the surface. So what is the electric potential on the surface? Electric potential on the surface is kq by r, and electric potential at a distance 2r is kq by 2r, right? So if you calculate the ratio, this is v1, this is v2, v1 by v2 will be 2 by 1, so it will be 2:1. Okay, 2:1. Simple. Now how do you get this? Try it. How kq by r divided by kq by 2r, so 2r will go up, kq will cancel, and the r will be down below, so rr also cancel, 2 by 1, right? So 2:1. Now let's move on to the fill in the blanks question. Molecule possessing permanent dipole moment is called dash molecule. So we already answered a similar question in our MCQ. So a molecule possessing permanent dipole moment is called, from the option, non-conducting, nanofarad, distance, polar, increases, decreases. First of all, many of them does not make any sense. Only one which making sense, that is polar. Okay, so a molecule possessing permanent dipole moment is called polar molecule, right? Next, the potential due to a dipole depends on, so potential due to a dipole depends on, from the option, non-conducting, nanofarad, polar is already done, distance, increases, decreases, obviously distance, right? So distance, so potential due to a dipole depends on the distance. As the distance between the plates of a capacitor is increased, the capacitance, now in this case there are two possibilities. Okay, non-conducting and nanofarad definitely not going to be working out. Either it will be increases or it will be decreases. Both make some sense, but in this case, as the distance increases, the capacitance decreases, right? So as the distance increases, capacitance decreases. You remember the formula, K epsilon naught A by D. So as you increase the distance, capacitance will decrease. Next, capacitance is measured in, from the given option, very clear, nanofarad, right? Nanofarad is the unit of capacitance. Next is, dielectrics are dash substances. So obviously from the given option, non-conducting is the answer. Okay, so capacitance, dielectrics are non-conducting substance. They are non-conductors, they are insulators, but in polar dielectrics there are already a dipole moment present, but they do not conduct directly. Okay, I hope that you have understood all these questions. Now let's go to the short answer type questions, 2 more questions. What is an equipotential surface? What will be the shape of the equipotential surface corresponding to a single point charge? Okay, any surface which has the same electric potential at every point is called an equipotential surface. The shape of the equipotential surface is spherical for a single point charge. Very important, if the charge is single point charge, the equipotential surface will be a sphere. Okay, and all the other equipotential surfaces will be concentric spheres. So suppose this is a potential V1, this is a potential V2. All the points on this surface potential will be V2. All the points on this surface potential will be V1. Okay, now tell me in the comment below for what type of surface what type of charge distribution equipotential surface will be parallel. Okay, parallel planes. There is a in your book there is a diagram, right? If you remember, there is a diagram. Now there it can be happen for two different cases, but if you can mention at least one, I will be very happy. Okay. Next, on what factors does the capacitance of a parallel plate capacitor depends? So before answering that, you have to remember that the parallel capacitance of a parallel plate capacitor is K epsilon naught A by D. So you can mention any. There are three factors on which it depends. Okay, you can mention any two of them. So what are those? First of all, I like to mention C is proportional to area. Okay, you can if you are writing like this, you have to write this equation. Okay, and explain the terms. If you are not writing like this, then you have to write in a proper word. Capacitance is directly proportional to the area, like this. Okay, or if you are writing like this, you have to write the equation first. What is the second point? Second point, you can write capacitance is inversely proportional to the distance. You have to write it in terms of word also. Okay, if you are writing like this, then you have to use the equation. What is the third point? Third point is capacitor is proportional to the dielectric constant between the plates. Okay, higher the dielectric constant, more the capacitance, right? So these are the 3 points. Now epsilon naught is a constant, so you cannot find any proportionality relation with epsilon naught. Epsilon naught is a constant value, so you cannot put this into this equations. But K is not a constant. You can change K based on what you are using inside the capacitor plates. Okay, so these are the 3 points. You can write any two of them, you will get full marks. Now next question, 23. Write two properties of equipotential surface. What are the two properties? I have given you 3 properties. In case the same question comes as 3 marks question, then you will say, sir, you gave us the question for 2 marker, but in our exam 3 marker question came. So to cover all the bases, I have given you 3 options. You can write any 2 of them. No work is done in moving a test charge over an equipotential surface. So in an equipotential surface, there was a question once, what is the work done to move a charge inside an equipotential surface? There was an objective question, right? So to move a charge in an equipotential surface, the work done is 0. So work done is 0 when you move a charge, say Q, to a distance r. If the potential is constant, then the work done is 0. This is the first point. Second point, electric field is always normal to the equipotential surface at every point. This is the first MCQ of our discussion today. If you remember, electric field is always perpendicular to the or normal to the equipotential surface at every point. Very important, at every point. Okay, no two equipotential surfaces can intersect each other. They are like field lines. Field lines can never intersect each other. Equipotential surfaces can also never intersect each other. Okay, now next question. In a parallel plate capacitor, this is also from one of your yearly question. Okay, in a parallel plate capacitor with air between the plates, each plate has an area of 6 times 10 to the power of minus 3 meter square, and the distance between the plate is 3 millimeter. Calculate the capacitance of the capacitor. Now the same question is given in your NCERT with a twist. They have added one more part to that question. We will solve that similar question in our actual numerical 5-mark numerical question, but this is from your yearly question. Only first part was asked as a 2-mark question. So how to solve that? Parallel plate capacitor with air between the plates. So what is the capacitance? C will be epsilon naught A by D. Okay, now air between the plate means dielectric constant is 1, so K is equal to 1, so we have avoided K. Now epsilon naught's value was given 8.85 times 10 to the power of minus 12. It will be given to you, don't worry. I have just to save some space, I have not given this value in this question, okay, but it will be given to you. Now area is given 6 times 10 to the power of 3 meter square, right? Now what is the distance? Distance between the plate is 3 millimeter. Okay, 3 millimeter means 3 times 10 to the power of minus 3 meters. Everything, every unit should be given, should be converted into SI units, meter, kilograms. Okay, so every units will be converted, should be converted into SI units. So in this case 10 to the power of minus 3, 10 to the power of minus 3 cancels, 3 2s are 6 and 8.85 times 2, it will be approximately 17.5. okay, so 6 to the 8 to the 16, 0.85 will be 1.6, 17.6, 17.5. okay, you can use the calculator because calculator is allowed in your PU board exam, so you can multiply this and you can find the value, and its unit will be farad. SI unit of capacitance is farad. Now 10 to the power of minus 12 has a special name, so we can write this as 17.5 picofarad. 17.5 picofarad, right? Now next question, 17.5 picofarad is the correct answer, so my answer is correct. Next question, 2-point charges 5 times 10 to the power of minus 8 coulomb and 3 times 10 to the power of minus 8 coulomb are located 10 centimeter apart. Find the point between the two charges where the potential is 0. Okay, this question can be a 2-mark question, can be a 3-mark question. Okay, sometimes it can be asked as a part of a 5-mark question where they will ask something else other than this. Okay, but I copied it from one of your previous year, I think mock test, one of the pre-board test exam paper. There this question was asked as a 2-mark question, so I kept it as a 2-mark question. Okay, it may be a 3-mark question, it has potential to be a 3-mark question, it has it can add one more part, and it can be a 5-mark question as well. Okay, but this is a very important, interesting question. 2-point charges, one is 5, one of the minus 3, both has 10 to the power of minus 8 common, so we are not worried about it too much. Okay, and they are 10 centimeter apart. They asked you find a point between the charges, say point P. Okay, it should be closer to the lesser charge. So find a point P between the charges where the potential will be 0. So how to do that? So suppose this is at a distance x from the 5 times 10 to the power of minus 8 charge. Okay, so from 5 it is a distance x. So from minus 3, what is the distance? 10 minus x centimeter is centimeter. Right, now what is the potential due to 5? Potential due to 5 is given by kq by r, that is the formula. Okay, I am writing this as 5, this is q5, everything is 5, k is constant, coulomb constant, q is 5 times 10 to the power of minus 8, and r is x centimeter, so x minus 10 to the power of minus 2. Okay, now what is V3? Similarly, we can write V3 is equal to k times minus 3 times 10 to the power of minus 8 x times 10 to the power of minus 2. Sorry, 10 minus x. Right, so this is the two individual potentials. Now they said the total potential is 0. How to calculate total potential? Total potential similar to that of electric field. Okay, we have calculated that. We have to calculate the net potential. We just need to add them. Now in this case they are scalar quantities, so we don't need to worry too much about the direction. In fact, we don't need to worry about the direction at all. Now net potential is 0. Okay, so that potential is 0. So net potential will be 0. Now put the values. So what is 5? 5 K 5 times 10 to the power of minus 8 divided by x times 10 to the power of minus 2. Don't worry about 10 to the powers, they will all cancel. K times minus 3 times 10 to the power of minus 8 divided by 10 minus x to the power 10 to the power minus 2. Okay, now if you multiply this minus and this plus, what you will get? You will get, this will be minus, right? And that should be equals to 0. Now take this to the other side. So K 5 times 10 to the power of minus 8 x times 10 to the power of minus 2 equals to K 3 times 10 to the power. Don't multiply with all these factors any numerical problems whenever you are solving. Try to avoid as long as possible. This is a very important tip for all my students, that whenever you are calculating, okay, try to avoid the calculation for most parts so that you can simply cancel them. If you have multiplied it, it would have been a very difficult task to first of all, it will be longer steps for you to multiply, then cancel again. If you keep it like this, you can easily cancel it in this step. Okay, so everything is cancelled. What is left? 5 by x. 5 by x equals to 3 by 10 minus x. Okay, now cross multiply. This will go here, this will go here. 50 minus 5x equals to 3 times x, 3x. So now this minus will go to the other side. So 5x plus 3x, 8x equals to 50. Okay, or x equals to 50 by 8, 4, 25. 25 by 4 is 6.25. Okay, so 6.25 centimeter is the answer. Okay, you have to add the unit here. 6. I guess the space is little cramped. I will give you this as notes, so that's why I am shifting this last part of the calculation in the other side so that you don't miss out on anything. Okay, so from here we can write x equals to 50 by 8 equals to 6.25 centimeter. Okay, so this is the answer. Slightly longer calculation, that's why I said I have taken it from one of the papers, but slightly longer calculation. So if this question comes in your board, maybe they will consider it and they will give you 3 marks for this answer. Okay, or maybe they will add one more small part and they will give you 5 marks for this. Good, great. Now let's move on to the 3-mark question. Obtain an expression for the effective capacitance of 2 capacitors connected in series. So 2 capacitors, this is a very important question. We know the formula, but still we have to do the derivation. This is a small derivation, 3 marks derivation. Okay, from this chapter most derivations are basically most questions, 3 marks questions are actually a kind of derivation. Okay, suppose we have 2 capacitors C1 and C2. They are connected with the external potential source V. Right, now if the potential drop across this is V1, potential drop across this is V2, then we can write this as, let me just rearrange this diagram so that no confusion is left. So potential drop across this is V1, potential drop across this is V2, this is C1, this is C2. Okay, now from the conservation of energy we can say V equals to V1 plus V2. Definitely only one potential source is here, and that potential is getting distributed across these two capacitors, so V is equal to V1 plus V2. Now if the charge passing through this is Q, okay, due to conservation of charge, same amount of charge will pass through this as well, right? Because if the charge that left from the battery, the same amount of charge will come back to it. Now this diagram is very, very important. Description of this diagram is not super important, but this diagram is super important. Now from there you have to write this V is equal to V1 plus V2, and the charge flowing through both of the capacitor is Q. Now from the definition or equation of capacitor, you can say, okay, of capacitor, okay, what is the formula? Q is equal to CV, in this case C1 V1, or V1 equals to Q by C1. Similarly V2 will be Q by C2, right? So for V1 is equal to Q by C1, V2 is equal to Q by C2, right? So we can say that now we know that V is equal to V1 plus V2. Or what is V1? V1 is Q by C1. What is V2? Q by C2. Now if we replace this using a circuit where only a single capacitor is there across the same battery, and we call this as C equivalent, such that the charge that is passing through this capacitor remains same, then that is the equivalent capacitor, right? So from that we can say that V is nothing but Q by C equivalent, okay, because for this capacitor we know that Q equals to C equivalent times V, right? So V equals to Q by C equivalent. So everything you have to show step by step, okay, then only you can take Q common from both sides. So Q by CEQ equals to Q common, you get 1 by C1 plus 1 by C2, okay, so this cancels, so you get 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Okay, now since it is only for two capacitors, we will simplify it slightly further, and we will do it as C1 C2 C1 plus C2, or C equivalent is equal to C1 C2 by C1 plus C2. Okay, so this is the final answer. You can leave it here as well, or you can solve up to this point as well, no problem, both will be considered and you will get full marks. Okay, now I hope this helps. These derivations you need to practice on your own. If you are not practicing, you will not be able to remember this during your exam. Okay, now question number 27, obtain the expression for the effective capacitance of two capacitors connected in parallel. This is also very simple. Here we have two capacitors, say C1. This is slightly easier and less common, but it has come in previous years, not recently, but it has come, so that's why I am giving you. So C1 C2 potential V. Now as you can see, because it is connected in parallel, okay, this potential V is applicable for the capacitance C1 as well as capacitance C2. Both capacitors are getting same battery, same potential, right? And the equivalent circuit will have, as usual, equivalent circuit will be same, that will be this. Also, one more thing I have seen among some of the students, some of them draw capacitor like this, some draw like this. Capacitors, if you are drawing capacitor, you have to be careful and try to draw them as much equal as possible and parallel. Okay, capacitors are two parallel plates. Try to draw them equal. They are obviously equal, but if there is a 0.1% difference, fine, but it should not be very much visibly difference. Okay, and if you mark them one small, one large, that represents a electric cell or electric battery. Okay, single means cell, some more means battery, but in general, in colloquial words, in our day-to-day language, we sometimes call it battery as well. That is not wrong, but the correct term is cell. Now, so obtain an expression for the effective capacitance. Now in this case, the charges will be different. If charge flowing through this Q1, charge flowing through this is Q2, okay, these two charges will be different, but charge here Q, charge coming back is also Q. Now in this case, this is C equivalent, the charge that is passing through is obviously Q. Now, so from the normal equation, Q1 is equal to C1V and Q2 equals to C2V. Obviously, Q is equal to CV, right? Similarly, what is Q here? Total charge. Total charge is Q1 plus Q2. Right? Now, for equivalent capacitor, Q equals to C equivalent V. Because in this case the total charge is Q as in the circuit. So let us replace this value. C equivalent V equals to C1V plus C2V. V is common, you can cancel them. So C equivalent is equal to C1 plus C2. This is very simple, easy derivation, and in my opinion, if this question comes, it will not come as a 3-marker question, but it might come as a 2-marker question. Okay, because it's so easy and simple. Now next question, give 3 results of electrostatic conductors. It is from your model question paper, one of the model question paper. Okay, I have never seen this question in previous year, but since it is given in the model question paper, I have included it in here. Inside a conductor, electrostatic field is 0. At the surface of a charged conductor, electrostatic field must be normal to the surface of every point. The interior of the conductor can have no excess charge in the static situation. Okay, these 3 points you have to remember. It is similar to the properties of equipotential surface, but in this case it is electrostatic conductors, not equipotential surface. Okay, so the properties are similar but somewhat different as well. Okay, because in the second point it seems that they are same. Yes, they are same, but other points are different. Now next question, derive the relationship between electric field and electric potential due to a point charge. This is the most star question of this chapter. Okay, most expected question from this chapter. Okay, triple star. Okay, this is the very common question, and the diagram given in your NCERT book unfortunately slightly incorrect. You have to correct it like this. So in your NCERT book the diagram is given here is plus, but it will be minus. Okay, this sign will be minus, and because electric field goes from higher to lower, okay, steepest, in whichever direction the electric potential decreases steepest, that is the direction of electric field. So in this case this is the direction of electric field, and in this diagram you have to make this correction. Okay, if you have NCERT book you can do the correction. Derivation I will do in this class. Okay, so first of all let us consider a unit, let us consider a test charge, say dq here. Okay, we are taking this charge from this point to say this point. Okay, and then we have to calculate the what is the work that we are doing and what is the force that we are applying, what is the force acting on this charge. The force acting on this charge, what is the force acting on a charge? So we remember that force acting on a charge is given by the charge times electric field at that point. So say electric field at this point is E1, electric field at this point is E2. Okay, what is the potential energy of this charge at this point? Potential energy at this point is, potential energy at V1 say is equal to the charge times the potential at this point, electric potential at this point, that is V. Okay, potential energy, so that's why let me not write it V, potential is V, potential energy we represent using symbol U. Okay, so this is U1. U1 is Q dV. Now what is the potential at the topmost point? Potential at the topmost point is dQ V minus dV. Okay, so this is the potential. Now what is the work done in our mechanical term? In our difference between them, the distance between them is dl. In our mechanical term, the work done is given by force times displacement. Force times displacement. What is force? Force is dq times E times delta L. Now in terms of electrostatic work done, the same work done can be written as the final potential energy minus initial potential energy. Right? So there are two different definition of work done. One is you are pushing it and someone is doing the work. Okay, based on the potential energy difference. So both are same. Both has to be same. So from here we can write this as dq V minus delta V minus dq times V. Okay, or you have to do it step by step, or dq E delta L equals to, if you break this up, if you break this, then you will get dq V minus dq delta V minus dq V. So this dq V cancels. What is left? So dq E delta L equals to minus dq delta V. This dq cancels. So E is basically equals to minus delta V by delta L. So the sign negative is very, very important. Without this negative sign, you will not get any marks. Okay, so negative sign is very, very important. This is the step that you have to follow. First you have to mention the force, then you have to mention the potential energies, then you have to mention that from the definition of work done. We can write work done is force time dl. Again from the potential work done we can get u2 minus u1. Just add a little bit some more sentences to whatever your understanding is, just express them in words. Okay, to complete this answer. Even if you write this, most teachers will give you 3 marks, but some teachers might think, okay, even if he has done it, maybe he has just remembered it and written it without even much understanding, so they might deduct 1 mark. Okay, but 90% of teachers will be going to give you 3 marks for this. Even if you write this step by step, one after another, you will get the marks. So first step is this, second step is this, third step is this. Okay, and then after this, this is the fourth step. Okay, so so that you don't get confused what are all the steps. Next question is now 5 mark derivations. Define electrostatic potential due to a point charge and arrive at the expression for electric potential at a point due to a point source. Okay, so what is the definition of electric potential? I am not going to write it on the board, but I am going to tell you. So the definition of electric potential is the work done required to bring a unit positive charge from infinity to a point on the electric field is called, it's the potential, electric potential of that point. Okay, so remember what are all the important things in this definition. To bring a unit positive charge, very very important, unit positive charge from infinity, very very important. Okay, to bring a unit positive charge from infinity to a point in the electric field is called the potential at that point. Okay, now let's find the electric potential due to a point charge. Okay, so we have a point charge here Q, and we are bringing a unit positive charge from infinity. Okay, let's say unit positive charge from infinity to a point. Now at some point between infinity and we are trying to measure the potential at our destination. This is our destination. So you started from your home and you want to reach your college. So in between somewhere your home is at infinity, your college is at P, and somewhere between your college and infinity your best friend just get into the bus. Okay, so you started chatting. So that point, say here, some distance, so this distance is R, this distance is R, somewhere between infinity and R at X distance your best friend just get into the bus, then you started chatting. Now at this point, okay, if you take this unit positive charge by a small distance, now there is a way to solve this, but I am using a simplest way to solve this problem. So in this case you take this unit positive charge to a small distance, say dx. Okay, you just slightly displaced it by a small distance dx. Now what is the work done to displace from x to this point dx? Small distance, very small distance. That work done is given by, what is the force acting on this unit positive charge? What is the force acting on this unit positive charge when it is at x? The force acting on this unit positive charge is the charge times the electric field. Right? The charge times the electric field is the work force acting on this point. And what is the displacement? Displacement is dx. Right? Now, or you can say this is nothing but E dx. Now at a distance x, what is the electric field? We already know the expression for electric field at some point is given by k q by r square. In this case, instead of r we will write x. Why we will write x? Because distance in this case is x. Simple, right? Or k q x square dx. This is the small work done to displace it by a small distance. So when the bus moved by a small distance, how much discussion you made between your you and your best friend? So you might have said hi. He may have replied hello. Then you will say what you have done yesterday. He will say I went to a game parlor. I played Call of Duty with my friends. I played PUBG with my friends. Like that. Okay. So these are the conversions that will happen from here to here till the entire path. But we are only considering a small distance. Okay. So, and that is the work done. That is the discussion that you have done. Now to find the total work done, what we have to do? We have to integrate this. We have to integrate this thing from where? Now we have to go back to our starting point, that is our home. From infinity to our college, that is R. Okay, from your home to the college, how much discussion you have done? Some portion you may have not have done much discussion, some portion you have done a lot of discussions, but total work done, total discussion is the integration. Now K and Q are constant in this case. K is obviously Coulomb constant, Q is given, so Q is constant. Okay, so only thing is distance is varying, infinity to R dx by x square. Now what is this integration? The integration is obviously, or we can say kq minus 1 by x. If you still wondering, if you still not very familiar with integration, you can do the step by step integration, like in this case x to the power minus 2 plus 1 divided by minus 2 plus 1, right? That is the integration, x to the power n. So this is how you can do the integration. You will get 1 by x minus 1 by x. Now put the values k, q minus 1 by r minus plus 1 by infinity. Okay, so this is minus kq by r. This is the work done. Okay, this is the work done. Now what is the potential? Potential means this is the work done by the external field. So work done by the external fields, that means potential will be minus W. Potential is defined by the negative of that work done. So you can say that this is minus of minus kq by r, or it is kq by r. Okay, the potential is kq by r. You have to remember these steps. So this is step 1, this is step 2, and this is step 3. All the steps are important. Okay, so you have to remember this. Some people directly write potential here and take it is as negative. That is also fine. Okay, I like to do it this way, sometimes that way as well, but both processes are fine. But don't worry, if you are following this process also, you will get full marks. Okay, now next question. Obtain an expression for potential, and this is a part question. As you can see in the previous question also, this was a split question. First they asked you the definition of electric potential. Next question was to find the electric field due to a point charge. Okay, so they will give you split question. If the derivations is coming from this chapter, it will not be a single derivation of 5 marks. They will ask more than one question from this chapter to answer, for you to answer. Obtain an expression for potential energy of an electric dipole placed in an uniform electric field. So many students are saying, sir, potential other day. So the potential is in this part. Okay, and one more thing, electric potential due to a dipole at any point on the dipole never came in the year. Okay, so electric potential due to a dipole never came in previous year, so I have not included that derivation in our discussion. But the formula you have to remember. You can write down the formula in your formula notebook and remember it. Okay, for numericals, for KSET, for JEE Mains, for NEET, that formula might be handy. Okay, but the derivation I have never seen in it is coming in previous years also, that if that question comes, that will be a single long answer type question. So there is no chance that that question even will be coming in your annual exam, so I have avoided that. Okay, but this is quite solvable. So here we have an external electric field. Okay, and there is a dipole, say at an angle theta. We have already seen how this works. Okay, in case of our electric field chapter, what is the torque acting on the dipole? So what is the torque? Expression for torque. If you remember the torque, the magnitude of the torque acting on the dipole is Pe sin theta. Okay, now they have asked you what is the potential energy of this dipole. So this is the torque acting on the dipole. Okay, and now they are asking you what is the potential energy on the system. Now in case they ask you what is the torque, then you have to calculate the force, multiply the distance, then show that. That will be a 2-mark question. Okay, this is a part of the 5-mark question, and in this case you can start itself with the expression for torque. You don't need to derive this equation. Clear? So first of all, what is potential energy? Potential energy is basically kind of work done. So we will try to calculate the work done. So suppose this was the initial position and you rotate it by some other angle. Initially suppose it was at an angle theta, and then you rotate it to another angle theta 2. Then what is the difference in the potential energy? That will be the work done, right? So now, work done is given by integration tau d theta, theta 1 to theta 2. Okay, so this is the work done, or theta 1 to theta 2 Pe sin theta d theta. Okay, or minus Pe cos theta, theta 1 theta 2, or minus Pe cos theta 2 minus theta cos theta 1. Sorry, extremely sorry. So the work done is tau d theta. You have to remember these definitions. Okay, if you have done that in your rotational motion chapter, then maybe you remembered it. If you have not done that, then you have to remember it for this chapter. Okay, Pe sin theta d theta. Now Pe is constant, so sin theta's integration is minus cos theta. Let me write it minus cos theta here only, theta 1 theta 2, or Pe, so it will be cos theta 1 minus cos theta 2. You can try, put the values with the proper sign, and if you shorten it, you will get this answer. Okay, so this is the work done. Now potential energy is equals to work done. It is not potential energy equals to the work done, that is Pe cos theta 1 minus cos theta 2. If you do this much, you will get the full mark. Sometimes they will ask, in their book they will say, okay, angle is now 90 degree, or they started it from 90 degrees, so in that case cos theta will be 0, so you can correspondingly find the exact potential energy. But this is a very simple, easy derivation. Only thing that you have to remember is this function and this function. Okay, if you put them, the rest of the part is just mathematics. Now define energy density of a charged capacitor. How is the energy density related to electric field present between the plates of the capacitor? Now this question I will not answer. I will leave as a homework. Okay, this question answer is given in your NCERT book directly. This is a small question. Okay, and obviously never came in your previous year question paper. That's why I am not going into this answer. You can answer this question and let me know in the comment below. Okay, just let me which page number of NCERT you found this answer. Okay, that's it. Or if you are following any other book, then you can mention that I have found this answer in this book, in this page number. Okay, if I have this book, I will check. If I don't have this book, then I have to guess that you have found it. Okay, but if you have NCERT at your book, you can find this answer in your NCERT book and tell me the answer. I am giving you a hint. It is given in the last part of the chapter. Okay, last part of the chapter, this answer is given. Now, next question: what are the polar and non-polar molecules? Two more question is there. So non-polar molecules are, in a non-polar molecule, the centers of positive and negative charges coincide. Okay, the molecules has no permanent or intrinsic dipole moment. The language you can ignore. Okay, but you have to mention that the definition only up to this much is compulsory. This is an optional line. Okay, in a non-polar molecule, the centers of positive and negative charges coincide. The molecule then has no permanent dipole moment. A polar molecule is one which the centers of positive and negative charges are separated even if there is no external field. Okay, this is compulsory. Up to this much is compulsory. Such molecules have a permanent dipole moment. Okay, so this is the definition for polar and non-polar. Okay, derive the expression for the capacitance of a parallel plate capacitor. So now they have asked you to find the so this is the part B. So parallel plate capacitor capacitance you want to find. So here we have two capacitor plates. Suppose this side is charged with plus Q, this side is charged with minus Q. Okay, now we are trying to find the capacitor. To find the capacitor, first of all, we need to realize that what is the electric field inside this capacitor. Okay, so first we will try to find electric field at some point A inside the capacitor. The distance between the plate is D, the area of the plate is A. Inside the capacitor, the dielectric constant, we are not assuming it is air field, assuming right now it is air field. Okay, and dielectric medium is air, so permittivity is epsilon naught. Okay, now electric field due to a charged plate, one-sided charged plate, is given by Q by epsilon naught by sigma by 2 epsilon naught. Okay, sigma by 2 epsilon naught. What is sigma? Sigma is charge density, not any charge density. Sigma is surface charge density. Okay, so due to a singly charged, this is singly charged means only one side is discharged. Okay, these two plates are locked with each other, so this side is positively charged and this side is negatively charged. There is nothing on the other side, there is nothing on this side, other charges already have flown. Okay, so these are locked charges, only one side is charged, and using Gauss's law you can calculate the electric field near a infinitely long plane charge, a sheet of charge, that is given by E is equal to sigma by 2 epsilon naught. And for all practical purposes we can consider these plates to be very, very long. Okay, so you can consider them to be infinitely long. Okay, now so E is equal to sigma by 2 epsilon naught. Now if you want to have some charge here, okay, if you have some charge, say delta Q, what is the force acting on this charge? Force acting on this charge is dq times E. One more thing, sorry. So the electric field due to this positive plate will be in this direction and its value is this. Electric field due to negative charge will be again in the same direction and its value will be the same. So the net electric field will be E plus E minus, because both the electric fields are in the same direction. So the net electric field will be sigma by 2 epsilon naught plus sigma by 2 epsilon naught equals to sigma by epsilon naught. Okay, if you add both are 1 by 2 1 by 2, so 1 by 2 plus 1 by 2 will be 1, right? So it will be sigma by epsilon naught. Now the force acting on a test charge, say small dq, you want to transfer it from say positive to negative, or on the other way also, whatever way you want to, just want to transfer a small charge dq from one plate to another, and you want to find what is the work done. So to calculate the work done, the force, first of all you have to calculate the force. The force will be dq times E. The force will be dq times E, right, or dq times sigma by epsilon naught. This is the force. Now what is the work done? Work done is, what is the distance between them? The work done is nothing but the distance between the plates times force, Fs, right? And cos theta is here the angle is 0, so cos theta is 1. So F is dq sigma by epsilon naught times d. Okay, so this is the work done. Work done is potential energy. Potential energy means electric potential. Now since suppose this is connected across a potential difference of V. Okay, it is connected across a potential difference V. Then what is the potential energy? Potential energy is dqV. This test charge, potential energy of this test charge will be dq times V. So from there you can cancel dq, okay, and you can write V equals to sigma by epsilon naught times d. Okay, there is one more way to solve this thing. You can apply any one of them, no problem. Okay, this is one of the easiest way to remember potential energy and potential, or you can use E is equal to dV by dl, but that will be slightly complicated. You will be considering what is dV, what is dl. So better I find this is much easier than that method. Okay, so this is V is equal to sigma by epsilon naught d. Okay, now what is sigma? Now we have to find sigma. Sigma is surface charge density. Surface charge density means one of the charge, any one of the charge you can consider, divided by the area. Charge divided by the area is surface charge density. So you can write this as Q by A and epsilon naught times d. This is the potential difference. Now what is capacitance? Capacitance can be written as Q is equal to CV, right, or C equals to Q by V. Now put the value of this V in that equation. Okay, so Q divided by QD divided by epsilon naught A. Okay, so this epsilon naught A will go up, divided by D. Q cancels. So this is the expression for capacitance. For 3 marker this is sufficient. For 3 marker this is sufficient expression to write, but if you have some time you can add one more line where you say if in case of having air, if there is a dielectric medium present, then that capacitance becomes K epsilon naught A by D. Okay, easy. Now question number 33, this is a numerical question. It is also 2-part question. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. Okay, so first part is calculate the potential at a point P due to a charge of, so charge is here, this is point P, okay, charge is 400 nanocoulomb, located 9 centimeter away, 9 centimeter away. Okay, so how can we calculate the potential? Potential formula simple, KQ by R. Very simple. So K is 9 times 10 to the power of 9, Q is 400. So now in this step you have to put the values. Why? Because they have asked you to calculate the potential, and to calculate that potential, the exact value, you will get marks, right? So that's why in this case you have to calculate the values. R is 9 centimeter. 9 centimeter means 9 times 10 to the power of minus 2. This you should make a habit. Okay, whenever there is a centimeter, you have to put a 10 to the power of minus 2. Now 9 cancels, this 10 to the power of 9, this 10 to the power of minus 9 cancels. So we get 400 times 10 to the power of 2. Okay, so the potential is 4 times 10 to the power of 4. Okay, yes. So 4 times 10 to the power of 4 volt is the potential. Now next part is obtain the work done in moving a charge of, so this is a very simple solution, right? I don't think this problem is very difficult. This is from your model question paper. Okay, obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. Does the answer depend on the path along which the charge is moved? So work done is the potential energy, that is the charge times potential. Simple. Okay, force is QE, potential energy is QV. Okay, so 2 nanocoulomb charge. 2 nanocoulomb is 2 times 10 to the power of minus 9 volt. Potential is 4 times 10 to the power of minus 4, and the unit will be joules. Because it is a work done, you have to mention the work unit. Okay, that is joules. Okay, so it will be 4 to the 8 times 10 to the power of minus, sorry, this is plus 4. Okay, this is plus 4, minus 5 joules. Okay, or you can write this as 80 microjoules. This is fine, both of them are fine. Now work done is independent of the path taken. Work done in this case is independent of the path taken, because potential, electric potential is a conservative field. So electric field is a conservative field, so work done is independent of the path. It only depends on the potential, final and initial point. Okay, so here you can say that work done is independent of the path. Okay, they have not asked you for any explanation, so you can explain, it is optional, but work done is independent, so it does not depend on path. You have to mention that. I have seen students, they are solving the numericals correctly, but the last part where some extra question, some extra part is asked, they are not able to answer that, they forget that to answer. Okay, so the answer is 4 times 10 to the power of 4, 8 times 10 to the power of minus 5 joules, and no, does not depend on the path. Okay, clear? Now let's move on to the next question. 3 capacitors of capacitance 2 microfarad, 3 microfarad, 6 microfarad are connected in series. Okay, determine the effective capacitance of the combination. Okay, so first 3 capacitance, C1 is 2 microfarad. Okay, I am keeping the microfarad for now. 3 microfarad, and C3 is 6 microfarad. Okay, so what is the equivalent capacitance? So equivalent capacitance, obviously 1 by C1 plus 1 by C2 plus 1 by C3. Sorry, again I am doing this mistake. I have seen students doing this mistake. I did it because I am in a hurry to complete this class as quickly as possible. So but don't fall for this stuff. This is 1 by CEQ. Okay, so 1 by 2 plus 1 by 3 plus 1 by 6. If you take the LCM, it will be 6. So it will be 3 plus 2 plus 1. So 3 plus 2 is 5, 5 plus 1 is 6. So 6 by 6, that is 1. So C equivalent is 1 microfarad. Very simple. Already you got scored 3 marks. Now find the potential difference across 6 microfarad capacitor if the combination is connected to a 60 volt supply. So there are 3 capacitors who are connected, right? Now they said they have connected this to a 60 volt supply. Okay, 60 volt supply they have connected, and they asked you what is the potential difference across this V6. How to do that? For that we will use this equivalent capacitance first to calculate the charge in the circuit. Now we know that in series combination charge is same for all the capacitors. So first of all, using the C equivalent, we know that Q is equal to C equivalent times V. C equivalent is 1 microfarad. Microfarad, I am keeping it as microfarad. I am not changing it because eventually the microfarad will be cancelled. So don't worry about it. And times 60. Okay, so 60 units. Okay, so this is the charge. Now what is the potential drop across this 6 microfarad? If the potential drop is V6, then again we can write Q is equal to 6 microfarad times V6. Okay, or what is Q? Q is 60 times 6 V6, or V6 is equal to 60 by 6, that is 10 volt. Okay, 10 volt is the answer. Okay, easy question, not super difficult. If you practice this kind of questions twice, you will be able to answer this question, especially the second part. First part is easy. First part, I hope most of you will be able to solve it, except some mathematical error, you will be able to solve it clearly. The second part, you need to practice a little bit more. Okay, what is the steps involved here? Total charge is constant for all the capacitors. So if you can calculate the total charge, you just need to find the potential and this capacitor, then you will be the same charge, right? So Q equals to CV for equivalent circuit. Similarly, Q is equal to the potential across this times its capacitance. Okay, now so answer is 1 microfarad times 10 volt. Next, in a parallel plate capacitor with air between the plates, each plate has an area of 12 times 10 to the power of minus 3 meter square, and the distance between the plates is 3 millimeter. Calculate the capacitance of the capacitor. In this case, they have given you epsilon naught 9 times 10 to the power of minus 12, and you can see this is the part 1 of the problem. So what is the problem? C equals to epsilon naught A by D. You have to apply this formula to calculate the capacitance. This is the first part. So epsilon value is already given, 9 times 10 to the power of minus 12. Area is given 12 times 10 to the power of minus 3. Distance is given 3 millimeter. We have already solved a similar problem. If you remember, 3 millimeter means 10 to the power of minus 3 meter. Okay, that case 6 times 10 to the power of minus 3 was given, and we have taken this as 8.85. Similar problem. Okay, 4 nines are 36 times 10 to the power of minus 12, or 36 picofarad. So this is the capacitance of the capacitor. This is the for part 1. Next part is, if this capacitor is connected to a 100 volt supply, what is the charge on the each plate of the capacitor? This is also very simple. Q is equal to CV. People often confuses by reading the question. So to avoid confusion, what you have to do, you have to practice more and more problems. Okay, so Q is equal to CV. They asked you to find the charge on each plate of the capacitor. Each plate, both plates will have the same charge Q. This is as simple as that. So C is 36 picofarad or 36 times 10 to the power of minus 12. Voltage is 100 volt. So it will be 36 times 10 to the power of minus 10 or 3.6 times 10 to the power of minus 9 or 3.6 nanocoulomb. Okay, charge, we are finding charge, so unit will be in nanocoulomb. Okay, so this is coulomb, this is coulomb, this is coulomb, this is nanocoulomb. So we have absorbed this 10 to the power of minus 9 inside this symbol. Okay, so the answer is 36 picofarad and 3.6 nanocoulomb. Right, so we have reached the end of this lecture. I hope you enjoyed this session. Don't forget to like, share and subscribe and share it with your friends. I will be back with a new chapter in our next class Tuesday. Till then, bye.